The McDonnell XP-67 BAT or Moonbat was a prototype for a twin-engine, long-range, single-seat interceptor aircraft for the United States Army Air Forces. Although the design was conceptually advanced, it was beset by numerous problems and never approached its anticipated level of performance. The project was cancelled after the sole completed prototype was destroyed by an engine fire. Design and development. Origins. In 1940, the U.S. Army Air Corps issued Request for Proposal R-40C, requesting designs for a high-speed, long-range, high-altitude interceptor intended to destroy enemy bombers. The specifications were very bold, encouraging manufacturers to produce radical aircraft that would outperform any existing fighter in the world at the time. The aerospace parts manufacturer McDonnell Aircraft, eager to begin manufacturing its own aircraft, responded to the proposal with drawings and specifications of the proposed Model I, which would be powered by an unusual geared drivetrain with a single Allison V3420 engine buried in the fuselage powering twin wing-mounted pusher propellers in the wings. However, 22 other manufacturers also issued proposals to meet the Army's request. The McDonnell proposal had relatively unimpressive anticipated performance, and its odd drivetrain was unproven. The Model I fell in 21st place when the 23 proposals were examined and scored. The proposals that were accepted included the similarly ill-fated XP-54, XP-55, and XP-56. Despite the apparent setback, Air Corps leaders were impressed by the nascent company's efforts, and granted McDonnell a $3,000 contract to re-engineer the aircraft. Final design. McDonnell engineers returned on June 30, 1941 with the Model II, which was also rejected, so it was reworked into the Model II, which emerged on April 24, 1942. The new design was powered by a more traditional layout, a pair of engines and wing-mounted nacelles with four-bladed propellers in a tractor configuration. However, the design was still quite ambitious. The design team tried to maintain a true airfoil section through the center fuselage, merge the rear portions of the engine nacelles with the wing, and radically fillet all edges of the fuselage and nacelles into the wings in an effort to reduce drag. The design used laminar airfoil sections throughout. McDonnell designers promised that the design would deliver a top speed of 472 miles per hour, 760 kilometers per hour, with a gross weight of 18,600 pounds, 8,440 kilograms, although the anticipated gross weight was soon increased to a somewhat more realistic 20,000 pounds, 9,070 kilograms. On September 30, 1941, the USAF granted McDonnell a $1,508,596 contract, plus an $86,315 fee, for two prototypes, a wind tunnel model, and associated engineering data. The Model IIA was designated as the XP-67. The production aircraft was intended to have a pressurized cockpit, an innovation at the time. A number of armament configurations were considered including 6.50 in, 12.7 mm, machine guns, 420 mm, .79 in, cannon, and even a 75 mm, 2.95 in, cannon before the configuration of 637 mm, 1.46 in, M4 cannon was chosen. Power would be provided by two Continental 14-1431 inverted V12 engines, fitted with turbo superchargers, and the engine exhaust gases would augment thrust. Testing. An extensive aerodynamic test program of the numerous advanced aspects of the design was begun by McDonnell, NACA, and the University of Detroit. The design demanded skin that was perfectly smooth and precisely shaped to maintain its laminar flow characteristics, mandating the development of new construction techniques, as the company had never produced an entire aircraft before. Wind tunnel testing uncovered problems with engine cooling airflow through the engine nacelles, which were never fully resolved. Difficulties were also encountered in obtaining engines, as wartime production demands hampered Continental's efforts to deliver running examples of the experimental 14-1430 engines to competing aircraft test programs. The project was also delayed by intense competition for testing time at the NACA Wind Tunnel facility in Langley, Virginia. The first XP-67, 42 to 11,677, was ready for ground trials on December 1, 1943. The aircraft was fitted with 14-1430-17/19 engines and General Electric D-23 turbo superchargers, but no pressurization equipment or armament was installed. On December 8, the aircraft was damaged by fires in both engine nacelles, caused by a malfunction of the exhaust manifold slip rings. By January 6, 1944, the damage was repaired and the XP-67 made its first flight, which ended after 6 minutes due to engine trouble. After modifications were made to the engine installations, 2 test flights were carried out. On the 4th flight, the engine bearings burned out when the engines were accidentally overspeeded. By this time, it was becoming obvious that the XP-67 was hampered by a serious lack of power. The engines were only delivering 1,060 HP, 790 kilowatts, well short of their promised 1,350 HP, 1,007 kilowatts, rating. Company founder Jim McDonnell, frustrated by engine procurement delays and the XI-1430's subpar output, began to campaign for funding to re-engine the prototype with a pair of Allison or Rolls-Royce piston engines augmented by auxiliary Westinghouse turbojets in the aft nacelles. Although McDonnell promised a very impressive 500 miles per hour, 805 kilometers per hour, top speed with the new power plants, the Army rejected the proposal, demanding more testing of the existing design. As a result of wind tunnel tests, the tailplanes were raised 12 in, 31 centimeters, while the XP-67 waited for replacement engines. Trials. On March 23, 1944, flight trials restarted. U.S. Army Air Forces pilots finally got to fly the aircraft on May 11, 1944, and judged the cockpit layout fair and ground handling satisfactory, but deemed the aircraft underpowered due to its poor initial rate of climb, slow acceleration, and long takeoff roll, particularly when operating with only one engine. Other flight characteristics were generally good during gentle maneuvers, stick forces were light, roll rate was adequate, and control was effective at all speeds with good longitudinal stability. However, a tendency to Dutch roll was prevalent. The prototype also displayed several disturbing behaviors as its stall speed was approached. It began to buffet well above the actual stall speed, it felt tail-heavy in fast turns, and its nose would tuck upwards during the stall. The problems were serious enough that test pilots declined to test the XP-67's spin characteristics, fearing that a spin might be unrecoverable. This irregular and unstable stall behavior has been attributed to advanced aerodynamic principles that were not fully counteracted until the advent of electronic stability controls years later. Although the final flight test report was generally positive, the aircraft's maneuverability was deemed inferior to existing types such as the North American P-51 Mustang. Upon return to the factory, the cooling ducts were reworked. Several problems were cured during the ensuing test flights, but the engines continued to be plagued by chronic overheating and deficient power output. The XP-67 only reached a confirmed top speed of 405 miles per hour, 652 kilometers per hour, which was far short of its promised top speed of 472 miles per hour, 760 kilometers per hour, and was unremarkable compared to other fighters in service at the time. Cancellation. On September 6, 1944, the starboard engine of the XP-67 caught fire during a test flight, and test pilot E. E. Elliott executed an emergency landing at Lambert Field in St. Louis, Missouri. He attempted to park the craft pointing into the wind to blow the flames away from the airframe, but the starboard main landing gear brakes failed, pivoting the XP-67 so the flames blew directly towards the aft fuselage. Elliott escaped safely, but the blaze gutted the fuselage, engine, nacelle, and starboard wing. The aircraft was a total loss. The destruction of the lone flying prototype dealt a serious blow to the entire program because the second prototype was only 15% complete at the time. Army leaders decided to re-evaluate the XP-67, ultimately deciding on September 13 that it offered no significant advantages over existing fighters already in service. The project was cancelled, the remains of the first prototype were scrapped, and work was halted on the second prototype. Specifications: XP-67. General characteristics. Crew: 1, pilot. Length: 44 feet 9¼ in, 13.65 m. Wingspan: 55 feet, 16.76 m. Height: 15 feet 9 in, 4.80 m. Wing area: 414 ft2, 38.50 square meters. Empty weight: 17,745 pounds, 8,049 kilograms. Loaded weight: 22,114 pounds, 10,031 kilograms. Max takeoff weight: 25,400 pounds, 11,521 kilograms. Power plant: 2 times Continental 14-1430-17/1912 cylinder inverted V liquid cooled engine, 1,350 HP, 1,007 kilowatts, each. Performance. Maximum speed: 405 miles per hour, 352 knots, 650 kilometers per hour, at 25,000 feet, 7,600 m. Cruise speed: 270 miles per hour, 235 knots, 435 kilometers per hour. Range: 2,385 miles, 2,074 nmi, 3,837 kilometers. Service ceiling: 37,400 feet, 11,400 m. Rate of climb: 2,600 feet/min, 12.7 m/s. Wing loading: 53.4 lb/foot2, 260 kg/m2. Power/mass: 0.06 HP/lb, 0.09 kW/kg. Armament. Guns: 6 x 37 mm, 1.46 in, M4 cannons, never installed in prototype. Roll interceptor. Manufacturer McDonnell Aircraft. First flight January 6, 1944. Status cancelled on September 13, 1944. Primary user United States Army Air Forces. Number built 1. Program cost $4,742,746 US.
Please subscribe and thanks for watching.